Alright, so in this tutorial we're going to show you how to solve a problem in which you're trying to solve for the final temperature of the system. It's a somewhat complicated problem, so we figure we'd break it down in this video more so. So the first thing I'm going to do is start by reading the problem. It says, given that the specific heat capacity of aluminum is 0.903 joules per gram degree Celsius, calculate the final system temperature if a 110 gram block of aluminum at 95 degrees Celsius is placed into a calorimeter containing 75 grams of water at an initial temperature of 27 degrees Celsius. So like always, we want to use that 6-step method, and we want to try and plug in all of the information from our word problem into some type of organized chart to help us with our calculation. So I'm going to try and see what information is given to me in the problem with respect to aluminum. Again, from our previous tutorial video, we went through what units, what are the respective units for these different variables. So we're not going to do that. You can check on the slideshow in our previous video to see that information. Q is energy. The unit for Q is joules. In my problem, I do not see joules anywhere in here, so at some point I'm probably going to need to solve for Q. For my mass, it's given to me right here in the problem of 110 grams. My specific heat of aluminum is right here. That's the unit for specific heat, 0.903 joules per gram degrees Celsius. Delta T, a change in temperature. I do not see a change in temperature, but I do know that it was heated to an initial temperature of 95 degrees. Okay, so I have 3 unknowns for aluminum that we're going to have to try and find. We're going to do the same thing with water. If I look through the problem, I do not see a joule value for water, so that's going to be left blank. The mass of my water is 75 grams. The specific heat of water, again, that's a known value. That's 4.184 joules per gram degrees Celsius. Change in temperature, same thing. I don't know what the change in temperature is because I don't know the final temperature. That's what we're solving for, but I do know that it has an initial temperature of 27 degrees Celsius. But we do know that this temperature right here is going to be the same because they're going to come into equilibrium. Now, the important thing to note is from our previous tutorial videos that we did learn that when 2 objects or 2 substances are put in together with each other and there's a heat transfer, one object is going to gain heat and one object is going to lose heat. But the important thing to note is the value for that heat energy lost or gained is going to be the same. However, one is going to be a positive value and one is going to be a negative value. So if I know from putting the aluminum in contact with the water, the aluminum is going to lose heat. So we know it's going to have a negative Q value. And we also know that water is going to gain that heat energy, so it's going to have a positive Q value. So what we can do with this information is we can say that negative Q is equal to positive Q. From this information, we can do a quick substitution because we do know that Q is equal to MC delta T. And once I know that, well, then I can make this substitution into this equation. And so I can say negative mass specific heat delta T. Again, this is of my aluminum. I'll write that over here. Is equal to the mass specific heat and change in temperature of my water. Because again, we're going to put a negative here on this side because the aluminum is going to lose heat and the water is going to gain the heat. So once I have this step here, then I just plug in the information that's given to me in my table that I organized. So I've got a mass of 110 grams, a specific heat of 0.903, and a temperature change, which I don't know what that is, but I do know that delta T is equal to my final temperature minus my initial temperature. And I'm going to use a variable of x just to kind of help from an algebraic standpoint. I'm going to say that my delta T is equal to x minus 95 degrees. And that is equal to, again, we're going to plug in the information we have for water, 75 grams, specific heat of water is 4.184. And then my delta T for this one is going to be x minus 27. Again, the reason why we can do this is because we do know that once these substances come in contact, they are going to reach a temperature at equilibrium, and that's what we're trying to solve for. So then it turns into an algebraic equation. How do we get x by itself? So the first thing that we're going to do is we're going to multiply these two values together to get a product of negative 99.33. I'm going to leave this alone for the moment. And then we're going to combine these like terms, 75 times 4.184 to get a value of 313.8 x minus 27. All right, now that we're at this point, then we're going to distribute a next step closer to getting x by itself. So we're going to have negative 99.33x, all right, plus, in this case, 9,436.35. Again, how did I get this number? I multiplied negative 99.33 times this negative 95 to get a positive value. Negative times negative gives me a positive. Again, I'm going to do the same thing. I'm going to distribute 313.8 to both of these values in the parentheses. So I get 313.8x minus, and then 313 times negative 27 gives me 8,472.6. Again, we're just trying to get closer and closer to x. So the next thing I want to do is I want to combine like terms. I want to try and get my, the easiest way for me to look at this is try and get my x over here and get my, my other value over here on this side. So I'm going to add 99.33x to both sides. And then I'm also going to get rid of this value by bringing it over here by adding 8,472.6. So after it's all said and done, when we do our calculations, we have 17,908.95 is equal to, and then we're going to add these two values together to get 413.13x. We're almost done. We've just now got to do our final step to get x by itself. It is multiplied by this value, so to undo the multiplication, we're going to do, we're going to divide it by 413.13. And so now we have x, which we know is equal to final temperature. And we plug that into the calculator, we get 43.39. And now, if you got this answer, I would be very pleased with your work. If you wanted to make sure that it's in correct sig figs, we look in our problem. We've got 3 sig figs, 2 sig figs, 2 sig figs, 2 sig figs, 2 sig figs. So my answer needs to be in 2 sig figs. So my final answer, TF, is equal to 43 degrees Celsius. And that is how you solve for a final temperature.